Okay, so non-polar molecule, because the shared pair of electrons, the donut is shared perfectly equally, is this chlorine Cl2. This HCl is a polar molecule because the slider for those electrons has moved over to the chlorine, right? And therefore chlorine has had more bites of that donut than hydrogen. Chlorine is fatter than hydrogen, and this seesaw would tip towards the hydrogen. Remember, these things are electron clouds, right? So I'm actually pushed the cloud towards the chlorine. So this is going to have more cloud, this is going to have less cloud, making it a very odd looking peanut. Whereas this peanut shape would be perfectly the same, as in like peanut in the shell peanut. Okay, and that's how you would draw the cloud density. If I had to draw the cloud density of these things, that would be perfectly even peanut, and this one would be the chlorine has more of it. If this was a seesaw, the seesaw would tip down to the chlorine. Everybody okay with that? Yes? Yes. Okay, ready for the complicated stuff. So the complicated stuff goes like this. Hold on, I gotta do that. I gotta move this up. What if I don't have just one slider? What if I have two sliders? Okay, now I have to pay attention to the shape. So hold on, let's just imagine I've got a little mouse, a big elephant, and a little mouse. And the elephant hogs up the donuts, right? So this shared pair that's here is going to go close to the elephant. This shared pair, this way. This shared pair here is going to go close to the elephant as well. Does the elephant have this sort of awkward seesaw where I've got one person here, another person in the middle, and another person here where this person's a big fat elephant in the middle? Is this teeter-totter going to move? No. So if it's linear, no movement. Or in other words, we would say non-polar. There's not one end that tips up. However, H2S is not linear. It is V-shaped. So actually the seesaw isn't like this at all. The seesaw then, starting over again, remembering our Vesper theory, that this is that should be S, like this. Okay, S hogs more of the donuts. It has a higher affinity for electrons, it has a higher electronegativity. You look up the numbers on the periodic table, right? Okay, so this shared pair of electrons here is going to lie closer to the sulfur, XO. Everybody okay with that?
Yeah.
And this shared pair of electrons here is going to lie closer to the sulfur. Everybody okay with that? XO. So now I have a V-shaped seesaw. Little mouse, big, fat, I ate all the donuts elephant. What happens to this seesaw? Does it balance out like our linear seesaw did? No, the V-shaped seesaw means that fat elephant is going to fall to the ground and those tiny mice are going to be flipping way up top. Do you see that?
Yeah.
Doesn't balance anymore. So this end becomes relatively negative, and down here where the mice are way up, or flying up in the air, is relatively positive. Do you get that?
Yep.
Okay? So this becomes a polar molecule. And indeed the final drawing is there. Have you done vectors yet? In math and physics?
Good afternoon, Computers. It's time for announcements.
I think that's it.
February 25th is this year's Edge Olympics.
Hold on.
So don't forget your mountain shirts and mountain team prize.
Keep going? I think it's keeping going. We'll see. We'll see. It's all learning experience. Okay, so let's look at these two diagrams just for the last little bit. If I remember that this is trigonal planar, and you remember it being flat on your table, right? You've just built this with the molecule models. You just built it. You remember it was flat, right? These vectors are going to go towards the carbon, towards the carbon, towards the carbon, towards the carbon. Carbon has a higher electronegativity. Those electrons are going to be held close to the carbon. Everybody okay so far? Is that molecule going to tip?
No.
Think of the molecule you built. Put those sliders towards the middle. What happens? Nothing. It just gets heavier in the middle. Nothing happens to my seesaw. So therefore this is non-polar. Whereas if I change the model that you drew a little bit, or made I mean, keeping these still hydrogens, but instead I take these off and I put great big fluorines. Do you remember fluorine? Do you remember what its electronegativity is?
4.0.
Very high, yeah, 4.0. So these point this way, these point this way. So I've got tiny mice, I don't know, medium-sized deer, and then a big fat elephant. So this whole molecule is going to tip towards the F. F's plural. And therefore this is going to be way high in the air, and that becomes relatively positive. Or, in other words, all the arrows are pushing towards the right. So the right ends up being negative. All that cloud is being blown to the right. So that ends up being thicker cloud on the right. So therefore that's my relatively negative bit, and this is my relatively positive bit. Okay with that? Over here it says, in summary, any symmetrical model compound has no dipole. Symmetrical being like it looks the same on both sides. CH2, CH2, do you see how it looks symmetrical? Therefore, non-polar. CH2, CF2, oh, different, polar. Get that?
Yes.
Okay, so tomorrow we're going to look at putting that into practice.